Let's look at an example. Here's a sequence, 2, 4, 8, 16, 32, and you can imagine where it's going from there. That's kind of the point of the sequence. It's a pattern. So the A1 here is 2. The A2, the second term in the series, is 4. The third term in the series, A3, is 8. And you can probably see what those, this is 2 to the first, 2 squared, 2 cubed. If I went 2 to the fourth, 2 to the fifth, and so on. So I have a formula for the general term, the AN term, or the nth term, which is 2 to the n. We could go to the next one. AN plus 1 is 2 to the n plus 1, but I'm really not elaborating on the pattern further by doing that. That's the definition of that sequence. That's a definition. And that's like a function. So this is something that I could call f of n. In the spirit of our f of x functions, an is the notation in sequences. F of n would be the functional notation. But they're the same. They're 2 to the n. Now we're going to look at a different way of looking at the same sequence, and this is going to be useful as we go and explore other sequences. A2, let's start with A2. You can see that A2 is 4, and it is 2 times A1, which is 2. A1 is 2. 2 times that is 4. Also, A3 is 2 times 4. A3 is 8. 2 times 4. So it's 2 times A2, the previous term. And in general, this pattern is called the recurrence. And it actually consists of two things. And we've seen this in differential equations where we have an initial condition and a differential equation. The initial condition tells you where the thing starts. The differential equation tells you how it changes. Same thing here. The first term tells you where it starts, and the recurrence relation, I'm going to put these two things together, but the important thing here is that AN, I did that totally wrong, AN is equal to 2 times AN minus 1. And that's the recurrence relationship between the two, between the terms, any two terms, consecutive terms. The next term is twice the previous term. Initial condition, description of the way it changes.